All right, so this is lesson chapter 2, the first part of chapter 2, so 2.1, and we're still on our first unit, energy and matter exchange in the biosphere. So topic 2 is on cycles of matter, and 2.1 is the role of matter in cycles of matter. So the role of water in cycles of matter. So when we talk about biogeochemical cycles, this is the route that water and other chemical nutrients take through the biotic and abiotic components of the biosphere. Hydrologic cycle is the water cycle. So anytime you see the word hydro, you know we're talking about water. So quick review of the water cycle. Let's start from the bottom. We have some groundwater, we have some storage, freshwater storage. There's water in oceans, so that will lead to evaporation, condensation in the clouds, water storage in the atmosphere. Eventually we'll have precipitation. That's where water will fall as ice or snow and back down to groundwater. There's also runoff into streams as well, surface runoff as well. And there's one more word here called transpiration. So recall that transpiration is how water evaporates from plants and trees, specifically from plants and leaves and trees. That is where we have water evaporating from their stomata. You probably remember that from Science 10. All right, so this is one of the videos on the water cycle. So next, we're going to look at properties of water. So water has many properties that make it an excellent carrier of dissolved minerals and other minerals, and it's also an effective medium for transferring energy. So one thing is that it's a universal solvent. Many things will dissolve in water. It has a relatively high melting point and melting and boiling point, and it has special adhesive and cohesive properties as well. Water has a high heat capacity. So let's take a look at first here hydrogen bonding. This hydrogen bonding that is in water gives water very special properties. So in water we have H2O. So water molecule is made up of 2 hydrogens and 1 oxygen molecule. So if we look at the diagram here, the red represents the oxygen and then the gray represents the 2 hydrogens. Each water molecule has a slightly positive charge near the hydrogen. So hydrogen is slightly positive and the oxygen is slightly negative. So you'll see the negative sign here by the oxygen. So this causes water molecules to be strongly attracted to other water molecules. So because of that negative and that positive. And that attraction is so strong that it becomes this bond called a hydrogen bond. And that's what gives water the special properties like cohesion, adhesion, and a high specific heat capacity. And that is also what allows ionic compounds in polar compounds to dissolve in water. And that's why water is called the universal solvent. So again, it's because of that slightly negative and slightly positive charge. So here again, we're just looking at another diagram showing how the hydrogens have that slightly positive charge and the oxygen shown in the blue has that slightly negative charge. And here we can see the hydrogen bond forming as well. So the attraction between that negative oxygen and a neighboring water molecule, specifically that negative oxygen is attracted to that positive hydrogen, and that forms that hydrogen bond. So we talked about water being a universal solvent. And the reason being is that polarity that we saw that water has, it makes water a good solvent for ionic compounds or polar covalent molecules. So again, water, it's a polar molecule because it's got that negatively charged oxygen end, and it's got the positive hydrogen end. And because of that, the negatively charged oxygen end of the molecule is highly attracted to the positive ion in ionic compounds. So in this example, we're looking at salt, sodium Na positive, and chlorine, which is a minus, Cl minus. So that attraction allows the positive and negative ions to be pulled apart and then allowing it to dissolve in water. So same attraction is happening with the negative ion and the positive hydrogen end of the water molecule. So here the Cl minus is attracted to the hydrogen, and then the sodium, which is positive, it's attracted to the oxygen, which was negative. So properties of water, continuing, we talked about cohesion. When we talk about cohesion, it's the attraction of water molecules to other water molecules. And this causes surface tension. So since water molecules are charged, they are also strongly attracted to each other. So water attracted to water, and results in water forming into droplets easier than other liquids do, and it's also responsible for the high surface tension of water. So here, surface tension, we have a water strider that can kind of walk on water because of the surface tension. That surface tension prevents the legs of the water strider from penetrating into the surface of the water. Next is adhesion. When we talk about adhesion, it's the attraction of water to other charged particles. So cohesion was water attracted to other water molecules. Adhesion is water molecules being attracted to other charged particles. So for example, glass, we have a glass of water here. Glass is slightly charged, so it's adhesion that allows you to fill a glass just over the top. Because some surfaces are slightly charged, water is attracted to them. Adhesion is also very important in plants. We had talked about xylem and phloem. You would have learned about that in Science 10. So xylem is that tissue that transports water. So water is being transported from the roots all the way to the leaves, and it's doing so because of adhesion occurring in the xylem. So lastly, water also has a high specific heat capacity. So basically what that means is that specific heat capacity is the amount of energy required to raise 1 gram of a substance by 1 degree Celsius. So it takes a large amount of energy for water to be warmed, and it releases a large amount of energy when it gets cooled, which is very important because it kind of controls climates. This property of water, it moderates climates, especially those close to a large body of water. So if you think about if you're at the beach and if you're walking on the sand, you'll notice the sand gets really, really hot, but the water stays cool, even though it's the same amount of sun. Even if it's the same amount of sun, the beach gets hot, the water remains cool, and it's because water has that specific high capacity. All right, so it's a couple of videos here on water polarity. So I'll pause it here. All right, so next we have water quality. And the quality of water impacts the health of the biosphere and the people who live in it, as well as other organisms and other species. So this is the diagram of the Great Lakes, showing pollution in the Great Lakes. Today, roughly 1/4 of Canada's population drink from the Great Lakes. And it's been a concern, the pollution in the Great Lakes, it's been a concern since the 60s when high levels of phosphates were found in the lakes because of household detergents. And because water is a universal solvent, it doesn't distinguish between bad and good solutes. So once pollutants have been dissolved in water, it's difficult to impossible to remove them from bodies of water. Drinking water in Indigenous communities. So since 2017, February, CBC reported that there's 71 First Nation communities that are still without potable tap water, meaning drinkable tap water. So it's because many communities are without water treatment plants or clean well water. And there is an initiative by the Canadian government that they are trying to provide safe drinking water to all those communities. But I don't think they've met that yet. That was for 2021, and I don't think that has been met yet.